This one is on using area to factor. So same kind of idea that we just had right here, but we're moving backwards. Instead of using the area boxes to multiply, we're actually using the area boxes to factor, to take out the greatest common factor. So here we notice that -5 is in common. If I take a -5 out here, I'd have to multiply by an x here to get that in the middle, and I would have to multiply by a -4. -4 times -5 is +20. So if I write it in two different ways, I can write the area as a product as -5 times x minus 4, or I could write it as a sum as -5x plus 20. This one right here, if we have a 10 right here, then what would be out here would be an x, right? 10 times x is 10x. So then if we fill in this box, it needs an x because x times x is x squared. So then if we want to write it as a product, we've got x times x plus 10, so that's a product. If we want to write it as a sum, we've got x squared plus 10x. Here we know that we need an a on the outside because a times a is a squared. So if an a is there, this needs to be -3 because -3 times a is -3a. So again, we'll write it as a product. That means a times a. And you can either write plus -3 or -3. So that's the product. And then the sum, those two things. And again, you could have written plus a -3a or -3a. Here, fill in the missing dimensions from the expression given. So here, if I take an x out of this expression, that's the same thing as putting an x right here, right? So, and the x squared plus the 3x are on the inside. So this goes on the inside of the boxes. I'm putting an x here. So an x needs to be there and a 3 needs to be there so that x times x is x squared, 3 times x is 3x. So we've got x plus 3 right there. Here, again, the sum goes inside the boxes. And then we're trying to write it as a product, so we're going to take that x out. They both have an x in common. Now, x times x is x squared, and 5 times x is 5x. So we can write this as the product, x times x plus 5. Here, the sum goes inside the boxes. We're trying to write it as the product, so I'm going to put the 3 out here as the length. And then what times 3 gives me 6x? That's a 2. 2 times 3 gives me 6x. And what times 3 gives me 21? That's a 7. Oh, you know what? That's a 2x. Because if I don't put the x there, then I wouldn't get the x there, right? So 2x times 3 is 6x. 7 times 3 is 21. So 3 times 2x plus 7 is the product. In this one, now we kind of have to do, there's an extra step we have to figure out. So we put 4x and -10 in here, right? Now we have to figure out what are we going to pull out to create the product. So I'm looking at what these two both have in common. If I pull out a 4, 4 doesn't divide evenly into 10, but 2 divides evenly into both. So I'm going to pull out a 2. And then leaving that, then 2x times 2 is 4x. And -5 times 2 is -10. So I can write this as a product of 2 times 2x minus 5. Now if you had pulled a 4 out, you would have gotten -10 divided by 4 right here. -10 divided by 4. You'd have gotten a -2.5 up here. And it wouldn't have been wrong. It wouldn't have been mathematically incorrect. But when we're trying to factor, we're trying to factor using integers. So you usually only want to pull out what divides evenly unless you have a really good reason not to. So here again, we've got a squared minus 5a. That's the sum. I'm going to pull out what they have in common. They both have an a that could go into them. They both have a factor of a. So from there, then I know a times a is a squared. And -5 times a is -5a. And then I can write this as a product. A times a minus 5. This one, we write the sum here. And then I want you to go ahead and finish this one on your own. I'm going to do 2 of these, and then I want you to do these 2 on your own. If I factor out here, so this is the same thing as up here. If you like to use the boxes, then you can use the boxes. Put a t squared here and a negative 6t here, and say to yourself, what's in common? Just like up here. I'm going to take a t out, because they both have a t in common, and then I'm going to put t times t is t squared, and negative 6 times t is negative 6. And then that product is t times t minus 6, right? So if the factoring, if these boxes, that's the whole point, is that these boxes, these area models, are a good way to organize your thinking. So if that's working for you, do it just like that. But if you want to jump to sort of the faster method, if you kind of see the structure behind it, you can just think through, what do these 2 have in common, right? And if they have anything in common, like both of them have a 3. 3 will go into both of them. So I'm going to just put the 3 on the outside. And then I'm going to ask myself, what times 3 gives me 6x? That's 2x. And then what times 3 gives me positive 21? That's 7. So that's the shortcut method. But again, if you feel more comfortable structuring it with the area model, use that to solve those 2 problems.